Assalamualaikum warahmatullahi wabarakatuh, and a very good day to you, Associate Professor Dr. Muhammad Arif bin Agam, and to Dr. Ahmad Hassan Sallehudin bin Mohamad Sarif. My name is Megat bin Mohamad Rosli, and my metric number is AW170140. Today, I'm going to give a presentation of my Bachelor Degree Project 1, which is titled Calorimetry Measurement of Heat for Peat Pellet Biofuel Energy. Next, I'm going to introduce several objectives of this project. The first objective is to fabricate the biofuel pellets by pelletizing the dry peat samples and mix it with flammable liquids such as petrol, kerosene, and diesel. Second objective is to analyze the elemental composition for peat by using the SAM EDX and to investigate the sample's functional group of carbon from peat powder by using the FTIR analysis. Last but not least, to compare the heat capacity for each pellet by using the calorimetry technique. With that said, this project holds these three objectives. For the research methodology part, the first thing that must be conducted is to survey the area of study, which in this case, that area is at Parit Botak, Batu Pahat, Johor. After gathering enough information, the next step can be proceed, which is the collection of samples at 5 different locations in the area. The additive that is to be used in these projects are petrol, kerosene, and diesel can be retrieved at any nearby gas stations. To obtain accurate data during the experimentation and analysis, the peat samples must undergo into preparation process. The raw peat samples that is taken from the area of study must be turned into fine powder form by using the grinding machine. After that, the raw peat sample that is now in fine powder form state will be compressed into 5 tons of pressure by using the hydraulic compressor that will change the shape of the samples into cylindrical pellet form. After the preparation process, the peat samples will be characterized in terms of its morphology structure and its elemental composition by using the SAM EDX analysis. The sample characterization process will be proceed by determining the functional group of the peat samples by using the FTIR analysis. Before the experiment starts, several data must be retrieved beforehand. The first data is to measure the volume of peat pellets before and after the addition of additive. The second data is to measure the mass of the peat pellets before and after the addition of the additive. The apparatus will be set up accordingly as shown in the display right now. As the water will be filled inside of the styrofoam cup and it will be heated up by the ignited peat pellet with additive below it. After receiving all the relevant data in this project, the next step will be to calculate the difference of temperature of water before and after the peat pellet combustion. Next step will be to measure the heat capacity in order to analyze the efficiency of peat pellet combustion by using the formula shown in the display. Then this step will be repeated with every peat pellet sample soaked with different type of additive, and the result will be compared to determine which of the sample produces better combustion efficiency. Moving on to the expected outcomes of this project, we will look into the SAM EDX analysis of the biomass sample. SAM EDX analysis is capable of delivering high resolution images of the sample by focusing electron beams to the surface and receiving backscatter electron signal. A group of researchers in Anadolu University, Turkey, carried out SAM EDX analysis of the biomass sample, and figures on the right depicts their result. To summarize this whole Bachelor Degree Project 1, we will look into peat as a new alternative biofuel energy resource, as peat has shown the potential to become one. With that being said, if this project objective becomes successful, it will open a new opportunity to Malaysia to have a new biofuel resource that can be changed into a new biofuel energy to ensure the energy security here in this country. That's all from me. Thank you very much for listening. Thank you for your time. Thank you to Professor and Doctor. Thank you.